So we got, okay, so we got parabolas. You guys tell me, do I solve for y in this problem, or do I solve for x? How come? Very good. I had the x squared, so I solve for y. And so I have 7y equals negative 4x squared. Divide by 7, y equals negative 4 over 7 times x squared. That's the equation for my parabola. So will that be vertical or horizontal? Vertical, because it's a y equals, generates a vertical parabola, and it does go down because it has the negative. So I will list off all the characteristics I need to identify. Direction, vertex, axis, focus, directrix, length of lattice, rectum, and A equals 1 over 4p is a formula that I will use every time you write those down. For half of the problems on your test, I will outline all of these for you, so you don't have to write them down and you know what you're going to be finding. I will tell you it's a parabola and you will graph it. But you will also have some problems where I won't tell you if it's a parabola or an ellipse or a hyperbola. You have to figure that out. I'll tell you how to figure it out, but so then you'll have to list these on your own. But for the first part, you'll have all these listed. You've already stated that the direction is down. Any questions how we got that? Negative makes it down as opposed to up, or left as opposed to right. We know this is vertical because it's a y equals, so it's up or down. The negative makes it go down. Vertex. Is there any shift? No. So it's 0, 0. I'm now going to draw the graph. Got my vertex at 0, 0. Axis of symmetry. Will this be a vertical line or a horizontal line? Vertical line. Awesome. What's the equation for a vertical line? X equals or Y equals? X equals 0. If you simply write 0 on the test, I will not mark it correct, because the axis of symmetry is a line, not a point, not a distance. It's a line, and this gives the equation for that line. Okay, in order to find the focus, the directrix, and the length of the lattice rectum, what value do I have to find? P! When I find P by setting up the equation, A equals 1 over 4P. So negative 4 over 7 equals 1 over 4P. How do I solve? Cross multiply. Negative 16P is equal to 7. Divide by negative 16. Whoop. P is equal to negative 7/16. So, from the focus, I travel 7/16. Which direction, up or down? Down, because the direction is down and your value for P is negative, so that tells you travel down. So just kind of, checking to make sure you're doing it all correctly. So I'll travel down 7/16, which is about a half, right? So about a half a unit. And after I've labeled that, let me now tell what the coordinate is of the focus. What is that coordinate? Very good. 0 and negative 7/16. The directrix. What do I do for that? Yep, I go the opposite direction. Instead of down 7/16, I will go up 7/16. Had a few people last hour that they would plot it, they would plot that point, and then they would just say, I'm done. But the directrix is not a point, it is a line. And it is perpendicular to the axis of symmetry, like so. And if you can't remember that, again, like I said on the test, in your sheet of notes, I think I have In fact, I'll tell you what, if you want to use 2 sheets of notes, if you want to have this one that I wrote and make your own, I don't care. Okay, if it helps you, fine. But I got a picture there for you where it shows what the Directrix is, right? So everything's labeled for you, okay? All right, so that's the Directrix. What is the equation? Since it's a horizontal line, it's an equation of y equals, and it'll be positive 7/16 this time. Very good. Length of the lattice rectum. What do? Absolute value of 4p. Very good. So that's the absolute value of 4 over 1 times negative 7 over 16. 4 over 16 reduces to 1/4. So you have absolute value of negative 7/4 or 7/4. Beautiful. I picked a problem that has fractions because I know that makes things a little bit more complicated. Okay. So if the length of the lattice rectum is 7/4, as soon as you get confused about a value like that, go ahead and turn it into a decimal if you want. Okay. Yeah. 7/4 is the same as 1.75. So almost, almost 2, I guess. So how many will you go in each direction? You'll go half of 7/4 or 7/8, which is 0.875. So you're going to go almost 1 unit in each direction. 7/8 of a unit in each direction. Okay? So 7/8 right there, 7/8 right there. That's my lattice rectum. That's my segment. I'm sticking to it. The parabola has endpoints of the lattice rectum. It starts at the vertex and it goes out from there. Perfect. What do you think about that? True or false? You have to know the directrix in order to graph the equation. False. So why even graph it? It doesn't even come up later. You'll never use the directrix again, probably in your natural life. Okay? The fact of the matter is that the only reason we're graphing is because the directions tell us to, and we want to remind you that the directrix it's part of the definition. Remember, the definition of a parabola is all points. So that's a point on the parabola, and that happens to be equidistant from the focus. So if that distance is d, then that distance also is d. Obviously, I haven't drawn this proportionally. It didn't work out quite right, but that's the definition of a parabola. All points that are the same distance from the focus and the directrix. That's the definition. So that's why we incorporate it, part of the definition. Okie doke. This point in the middle of the focus, people have satellites at home for their TVs. What do you call that thing that sticks out in the middle? Is there a name for it? I don't know. I guess maybe they call it the focus. Probably not. Okay, let's do the next problem. And we're done. Okay. We're going to change the problem because we can. I had a person one time, they didn't know how to do a problem on the test, so they just changed it. And then their response was, well, you do in class. Yeah. What? They did some stuff right, but really, I maybe gave them like 1 out of 4, but, said, sorry, I can't just do that. Well, you do it in class. Well, yeah, I guess I do. It's part of getting your degree, right? After you get a degree, if you want to change a problem, you can do it. So, it's not like I got to change the problems I had last year, but anyway, here we go. So, where do you even start? Well, what do you want to solve for, x or y? x because the square is on the y. So we solve for x. I subtract 12, 12x equals the quantity y minus 2 squared minus 12. Now, divide off your 12. Divide everything by 12. X is equal to 1/12 times the quantity y minus 2 squared minus 1. Now you see why I changed it to 12, don't you? You see, when I was making the problem up in my head, I was like, I want the vertex to be a certain number, but forgot about dividing by 12. So, let's list off all the important characteristics. We have the direction. We have the axis. We have the, vertex. I don't care about the order, I'm just trying to stay consistent. Axis, we have the focus. We have the directrix. We have the length of the lattice rectum. And we have A is equal to 1/4p. Some students last year, they were kind of angry. They said, why didn't you just write this down in the notes so then we don't have to write it every time? The reason why I have you write it is so that you're more likely to remember it. So I put it there for you in the test to help you save time, but hopefully it helps you remember. Direction, up, down, right, or left. What do you think? Right, very good. Horizontal, why? Because it's an x equals, and since it's positive, it will go to the right and not the left. Excellent. This is a tough one. Vertex. -1, 2. Now, most people look at it and they say, well, 2, -1. Hold on, everybody. Okay? Remember, the equation for the parabola is y equals a times x minus h quantity squared plus k. That means it has a horizontal shift of h, because it's attached to the x, and then a vertical shift of k, because it's solved for y. But if it's a horizontal parabola, we said x equals a times y minus k, quantity squared, plus h. See the difference? We wrote that down in your notes. This is the first time it's come up. I just want to make sure you see it. The vertical shift is attached to the y. You see it right here. The horizontal shift, as it's solved for x, is on the outside. That's why your vertex is -1, +2. Good? Okay. Now it's time to draw the graph. I think if you make it 8 by 8, this works out just fine. So when I sit down to supper and I ask Kira, I'm like, Kira, what are you learning in math right now? She's like, oh, we're multiplying numbers, or we're doing area. You guys ever have this conversation at supper? You're like, we're finding the focal diameter of the lattice rectum. Your parents change the subject then? Okay. So, I plot the vertex, -1, +2. Now that it's plotted, now I'm going to draw everything I can, and after I draw it, then I'll name it. It's harder for me to name it right now than it is for me to draw it, then name it. So the axis of symmetry, will that be horizontal or will it be vertical? Horizontal, because it will go the same direction as the parabola. So I draw my axis of symmetry. Whoa. Yeah, I didn't do a very good job of plotting that. Let's try that again. Back 1, up 2. There we go. Much better. So I drew my axis of symmetry. What's the equation for that line? Y equals 2. It's a horizontal line. Very good. I'll plot the focus. In order to plot the focus, what value do I have to find? P. I set up my equation. A equals 1 over 4p, or 1/12 equals 1 over 4p. Well, just look at it. What's p going to be? 3. So, if p is 3, the focus is how many units away from the vertex? 3 units. To the right or to the left, up or down? To the right. 1, 2, 3. 3 units to the right. There's my focus. That's my vertex. Name the focus. What is the location? 2, 2. Directrix. 3 units to the left. Some people last hour, they would just plot the point and they'd be done. The directrix is not a point. It's a line. You draw the line. Then you name it. Vertical. As Scott said, x equals -4. Got it. Length of Latus rectum. P is 3. Length of Latus rectum is the absolute value of 4 times P. So it is 12. Baker's dozen. Is it? Oh, I didn't know that. I just said it because it just sounded right. Baker's dozen is 13. Why did they say that? Just throw one in extra? Huh. Wow. Okay. One less than a baker's dozen. All right. So, length of the Latus rectum is 12. So how many units is that in each direction? 6. And I move from the focus 6 units up and 6 units down. And I draw my segment. Now I can draw the parabola and get the correct shape. And this is kind of my favorite part. I like to put a point. You don't have to do this. I just like to. I plot a point, and then I kind of check. You know, that length from the focus, does that appear to be about the same as that length? Nah, it's close, but if you draw a perfect parabola, those should be the same. It doesn't. If you draw a perfect parabola, whether you pick this point or look at the focus or the vertex right there, this distance is the same as this distance, right? And that should continue all the way. Doesn't matter. Or from the directions, you always pick perpendicular. It will always be perpendicular. So that distance and that distance should be the same. Pretty close. I give myself a B+. I'll go home tonight and practice. Okay, here you go. All right, so here's all I've done. Is Friday I gave you those 10 problems, okay? 6 of them were matching. 4 of them were graphing. Today I give you 2 more, 15 and 16. Those involve fractions. That's why I'm giving them to you so you can practice. I will run copies next hour of the Precalculus book so you guys can, have some stuff you can use in class. And that's all I have for you. Tomorrow we will move to ellipses and it'll just be a one-day deal. We'll fly through it. And you guys will have it right up in your brain. What up? Class is finished today at 1:39. 3 minutes.